Well, good morning and welcome to the messaging and event-driven track of TechCon 2025. I'm your track host, Ray Daniel, responsible for the integration portfolio here in the Americas. And we're really looking forward to, I think it's the seventh annual TechCon. And lots of great information as always. We're going to start off to begin with a well-known person in this community, David Ware, distinguished engineer, CTO, and all-around good guy to talk about async and how that factors into this. So we'll be running right here for an hour. At the end of the hour, we'll have some questions, just a poll on how the session was for you. So we'll get to that. And just in general, we're going to be, 4 sessions a day for 3 days in a row. And again, all being recorded so that you can come back to them at a later point in time. So with no further ado, David, it's all yours.
Thanks, Ray. Hello, everyone. As Ray said, welcome to TechCon. Welcome to the messaging and event track. It's good to be back again. Throughout this week, you're going to have lots of sessions. You're going to understand everything we've been doing in the IBM MQ space, also everything we're doing in the IBM event automation space, which is across sort of Apache Kafka, event stream processing, Apache Flink, that area. And I get to kick it off, this track, by talking a little bit sort of broader, a little bit talking about, okay, then the importance of async, because being asynchronous is what it's all about. Those technologies really do underpin those asynchronous use cases. But I also get to do the task of going, well, okay, then why are we talking about these different technologies? We've got these different technologies. In IBM, we think they are best of breed. We know they give you exactly what you need. And therefore, that's why we're providing you these great sessions and also this great information. So I get to talk around that. So I'm going to talk at that level. And to do that, I sort of need to explain to you why we have the technologies. Now, with the async world, I think to understand what it means, what the importance of asynchronous, we sort of just need to consider for a moment a life where we're synchronous, a life where everything we do has to be done there and then. We have to wait for it to complete before we can go about our lives. And at that point, okay, there are many things that we do synchronously. We get feedback from that directly. We want something to happen there and then. But so many more things are actually, you're just kicking off a process. The process is starting in the background, a real life process or a system, a solution that, we manage, maintain, we build, we develop. But really, asynchronous is what makes things possible. If we had to be synchronous, if we had to wait for these things to complete, we would, slightly ironically, spend all our time queuing. We would spend waiting for everything to be lined up exactly and available for us to be able to complete and check off every single last task and minutiae of the implications of performing whatever we're doing to finish before we could move on and the next one could be completed behind it. So asynchronous makes it possible. Asynchronous gives us greater scaling, greater resiliency, greater manageability, greater scale and sheer size of systems, not just volume, but being able to integrate these complicated systems with many different tasks, all interrelated in some way, and needing to interact or kick off one task after the next task, or be able to look into the outcomes of certain tasks and be able to process those. So being asynchronous really does make all of this possible. So based on that, well, asynchronous is asynchronous. And at that point, it's just about, okay, you drop something into the system, something looks after it, and then sometime later, something can process it, which means you've decoupled it to the point where at that point, you don't have to worry about it all happening in lockstep, which is a big tick. But the reality is, being asynchronous is really just a sort of a methodology. It doesn't really describe what you're trying to achieve. And depending on what you're trying to achieve, really dictates how you want the system to present it, how you want the system to look after it, what you're expecting, what's acceptable from your solution. You could say, you might be saying, okay, then I need this done. I want something to be done, and therefore, I'm going to be really unhappy if that doesn't happen. Now, I want to be able to do that asynchronously. I don't want to have to wait around for it. Therefore, I want to be able to drop it in and go about my business, and I don't want to doubt it. I need to trust it. I need to expect that this will complete. And that brings me one set of sort of understanding around being asynchronous. But then I could also be saying, well, okay, then I've done something. I think it's really interesting. Take a look at this. You might be interested in it. You might get some value from this. That again is asynchronous. I'm not going to wait for you to do that. I'm not going to go around everybody who might be interested and tell you all about it and then wait for you to tell me whether you are or not, or whether you've done it or not. So that's again another asynchronous flow and a way of integrating things. But the needs for these differ quite greatly when you start to think about what is it you really value, what is it you cherish, what do you need about these things. These are a spectrum. These are working across very different expectations about what is the most important aspect of achieving each of these different tasks. And that's why we introduce the two technologies, the technologies I mentioned right at the start, IBM MQ and Apache Kafka. Because these two technologies, as you're going to see, they focus on very different dimensions of being asynchronous. And with that, they cover that spectrum very well. Even with that, I wouldn't say that's 100% coverage of the entire spectrum. There are obviously edge cases where you've got extremes where you might need other technologies, but the majority of use cases are going to be covered by these two technologies side by side. But you might be thinking, well, okay, then obviously he's going to say that, this is IBM explaining this to me, therefore they've got an interest in making sure that you use IBM MQ. And we have an interest in you using Apache Kafka as well, because as you'll see when you watch the other sessions around IBM Event Automation, you'll see how we offer enterprise grade Apache Kafka. So really, I'm going to take it to the next level. The next level is, well, hang on a minute. Let's explain, let's look at these two technologies. Let's see what they're really about, what they're trying to achieve. And for that, we need to understand their purpose. We need to go right back to the point where these technologies effectively were created. They solved a problem. They evolved, obviously rapid evolution around it, but they quickly sort of became leaders in their field. And that's because they really nailed the solution. And the solution was for a particular purpose. So if we look at MQ, the purpose is asynchronous communication. The purpose is being able to have applications as if they're talking to each other directly. Synchronous communication is so much simpler. If I can just sort of have everyone in the room and I can be talking to them directly, things are easier. But as I explained, you can't do that at all times. You need to have that decoupling your interactions so that you can scale, you can have more resiliency. So MQ really set about, how do I solve that problem? How do I make it possible for you to be asynchronous, but as simple as possible for the applications, and to give the applications as much faith and trust in the solution, so that they don't have to worry about complexities. They don't have to worry about the what ifs of this happens, that happens, whether it's with the system or with the other applications that are consuming the data. So that was the objective for MQ. And now if we flip over to Kafka, you might think, well, Kafka, surely that provides me asynchronous communication. Surely that allows me to decouple my interactions. And yes, it technically does. It does provide that because it has that decoupling. I can drop events into a topic and I can process those at my leisure. So from that point of view, yes, I tick that particular requirement. But remember, this is about the purpose. This is what it's designed for, and this is what it becomes the best solution for, the best of breed. And actually that use case, that purpose is quite different. The purpose for Kafka was around event stream processing or log processing. It's about collecting data of activities that are going on, collecting that data, and rather than just storing it away and then coming back to it at some point in time, like batch processing, but actually doing it there and then, trying to do it as close to the point where it's generated so that I get as much value from it. I can get as much responsiveness to that data being collected and being analyzed. So it's really about gaining insights. That's the objective for Kafka. And in fact, there's a link to an article there written by the authors of Kafka, which explains that logic. It explains how messaging systems like MQ exist, but they're focused on a different thing. They're focused on this communication model, and that communication model requires certain things, and that was unnecessary for the gaining insights requirement of Kafka. So therefore, it evolved into something quite different. And if you look at sort of the everything that these technologies do, if you look inside them and how they work, you can see how every sort of level is tuned to those particular purposes, those particular use cases. So on MQ, for example, to be the best of breed in asynchronous communication, you need to focus on precision. You need to be exchanging data on those individual communications. You need to give the application sort of direct feedback and control. So the application feels empowered, but actually, yes, I have started this communication. This communication is now in the system and I can walk away from it. I know it's going to happen. I can have that trust. I can have that faith. And the application gets to control that. And to achieve that and to keep it as simple as possible for the application so that they get the control, but they don't get the complexity, then that leads MQ to be what we refer to as a smart broker. So a broker that takes on all that responsibility and a very sort of fixed way that you interact from an application point of view. And also because this is communication, and communication doesn't normally happen from a just, come to one place and everybody can talk. You need to have system to system capabilities. You need to have a loose federation of your system so that you can talk between pillars in your own enterprise or between different enterprises, between different entities. And MQ is used extensively to do that, and there's a reason why, because it provides this asynchronous communication model. On the Kafka side, the focus is on gaining insights. It's about that stream processing. And stream processing is effectively where there's no start, there's no end. It is a sequence of updates. And those updates need to be processed in sequence. And they need to be processed at a volume that you don't have to worry about, the magnitude of it. So you need to streamline that. You need to basically make the decisions around, okay, then my priority is to allow the data in so that I can process as much data and not have to worry about the implications. So with that, it's about sort of streamlining the broker, pushing the complexity out. The complexity goes out to the consumers. It goes out either into the application layer to worry about some of the what ifs. And rather than giving the application the control and therefore the trust, it works more on batching, timer optimization. That allows it to really pack data and communication into the available resources, but it doesn't give that same level of control. And even the data is managed in a way that makes sense from an event analysis, a gaining insight point of view. It prioritizes new data over old data. If I'm filling the system, rather than stopping new data coming in, I will age out old data, even if it hasn't been processed. Whereas on the communication side, what would happen is if we've accepted a message from you on the MQ side, that message is in. We've effectively given you a ticket. We've given you a receipt to say that's in there. And it's not the messaging system's responsibility to remove that message until a consumer does. So these things are very different approaches, and we can say, yes, they both do asynchronous communication. We can both do event streaming on both sides. But it's about, are they really designed for it? So another way to sort of represent that is sort of to try and pick out those different aspects and try and look at how the different technologies sort of overlay on top of that. Here we can see, MQ really excels on the precision, the communication, being message centric, those individual communications. And it has to take compromises. You can't be good in all these dimensions at all the same time. You can be good in one and you can be pretty good in the other, and maybe you can tune it into the other one, but you'll have to sort of, stretch it in from the other side at the same time. You can't go out into all 6 dimensions. So being sequence, data processing, streamlined, you tend to take little compromises there. Now, if I map Kafka onto this, you can sort of see the mirror, the flip of this. Sequence data is primary. Data processing, that's what you're trying to achieve. And event stream process, being streamlined rather than the precision, that's how you want to be running with Kafka. So here I can excel for different things. And if we overlay on our different purposes, the asynchronous communication versus the event stream processing, you can see how the 2 different technologies obviously drift towards what they're trying to satisfy. So based on that, you could just go, okay, then I can see a difference, a clear distinction between the 2 technologies. And we don't have to worry about it. We just use the 2 technologies. We've probably got both these use cases, particularly asynchronous communication obviously has been around for a long, long time and continues to be and is growing in strength. And event stream processing is also coming through as a more prevalent requirement in your system. So you can see how those 2 technologies live together. However, before we sort of do that and just drift away and just sort of agree on that, I think it's sort of worth pointing out some of the myths around this space, because these 2 technologies have been sort of bumping up against each other for some time now. And obviously with all technologies that come along, particularly a really popular technology, the same happened, MQ originally, a technology comes along and you start to think, well, okay, then it does this and it does that, and it solves these problems, and therefore these are the benefits, and you focus on that. And then statements get made, probably with context, and the context is sort of level and sort of explained, but that context sometimes gets watered down. That context tends to drift away, and just statements, very simple statements, sort of stay around. And these are some of the statements that if you go looking, you're going to find. So if you go looking at comparisons between MQ and Kafka, or message brokers and Kafka, you're going to find some of these statements. High volume or scale, it must be Kafka. An event stream and a queue are interchangeable. Kafka's more resilient and robust than message queuing. You need real time. In that case, you need Kafka. Exactly once is a thing that you just turn on. MQ is traditional. Kafka is a modern approach to messaging. These are all things that have been stated, and I'm sure some of you have heard them. You may even have said them yourselves, and I'm sure you had some reason or something behind that, but they tend to get, like I said, repeated without that context. So I'm just going to give a little bit of my own context on these before we move on, just on a couple of those. So we'll start with MQ is traditional. Kafka is a modern approach to messaging. Now, I see this when people are explaining what Kafka is. And what typically happens is, and it's normally not limited to MQ, it's limited, it's normally categorizing things. It's normally grouping together message brokers. And message brokers are going to be things like IBM MQ, RabbitMQ, ActiveMQ, and various others as well in that space. And they tend to get categorized as traditional. And therefore, there tends to be a sort of an insinuation, an assumption that they're traditional. That's an old way of doing things versus a new modern way of doing things, which is the Kafka approach. Whereas actually, it's really just a comparison between one way of doing something or looking at a problem and solving that problem, and a different way of solving actually a different problem, as we've been talking about. So it's really not about one is old and one is new. It's really trying to understand, why do we do the comparison? And when you sort of dig into it just a little bit, it tends to be the difference between traditional message brokers and Kafka. It tends to get quoted as, well, Kafka is a distributed append-only log. And a lot, particularly in the early days of Kafka, a lot of the description of Kafka really focused in on that. And this is a core distinction. This is why Kafka is a different approach, or a better approach than traditional message brokers. Now, there's a couple of issues here, okay? And some of them being a little bit pedantic, but the distributed append-only log is not a unique thing to Kafka. MQ, at the heart of every queue manager for MQ, there is an append-only log. That's how you get your recovery semantics. That's how we make sure that every single message is precious and every single message survives no matter what is thrown at it. So that's not unique. The distributed nature, which tends to apply to the fact that you can do workload balancing across multiple brokers in a Kafka cluster. Again, that's not unique. MQ clustering has been doing that for a long, long time now, much longer than Kafka. So you get workload distribution in the same way. So technically, a distributed append-only log is not a unique feature of Kafka. However, the unique feature of Kafka is that distributed append-only log is exposed directly to the application layer. The application layer is effectively given access to that log, whereas MQ and other message brokers have abstracted that away. Back to that use case that I was talking about. For asynchronous communication, they've implemented an abstraction level, and that abstraction level is a queue. And a queue is a really nice level of abstraction which hides the complexity from the application. The application can now just interact. It's not a coincidence that the example of what happens when you don't have asynchronicity is you have lots of queues. That's why you have the concept of a queue within message brokers, because I want to put something into the system, I put that into a queue. I know it's now safe in there, it stays in there until someone takes it out and processes it, at which point it's gone. And that's the queue concept. So it's not that MQ did that for fun, or that was an old way of doing things, or it's traditional versus new, or it's better or worse. It's just because it's tailored to the use case. That asynchronous communication, the queue concept, works very nicely in that model. Whereas if I'm doing event stream processing, do I need the queue concept? Maybe I don't need the queue concept. And if my application is willing and able to interact with a log and move forward and backwards and have certain things happen to it, and therefore be able to replay it whether I want to, or maybe it's due to a characteristic of a system, then that's great, because I don't then have to need that abstraction, and then I can go straight in with the append only log. So they're just different approaches, and that's as simple as that. It's not an old and new thing. Second myth: for high volume or scale, it must be Kafka. If you look at any description of Kafka, particularly when people are trying to describe it, trying to take you through it and why Kafka is a great technology, and it is a great technology, it tends to focus on high volume, high scale, high throughput, high whatever you want to call it. So why is that? And does that then map into that statement on the screen? For high volume or scale, it must be Kafka. Well, if we try and sort of lay this out, and we look at, say, on a dimension of, say, performance, let's call it performance for sake of argument. Let's put Kafka. I'm doing event streaming. So I'm in an event streaming use case, and I'm going to plot Kafka here, some arbitrary point along my scale for performance. And Kafka does perform very well. Like I said, it was designed for volume. It was designed to be able to be as slick as possible. And you code your applications into a streaming mode. So I'm not worrying about, completeness. I'm not worrying about exactly once delivery. I'm not worrying about the fact, whatever is happening. And I'm interacting in this constant stream. Kafka sits here. If I then try and take that same streaming application, that same pattern, and base it on top of MQ, and maybe tune MQ around that sort of model, certain assumptions, then Kafka is going to outperform MQ, because MQ is not designed to do this. So from our point of view, you can see on the screen, well, okay, then Kafka is the high volume and scale solution over and above MQ. But this is just one use case. So, and that's not even the MQ use case. So let's take the MQ use case, which is communication. And for communication, and we're talking now about communication where we've got some checks and balances, we want to trust that a message, once it's in the system, it's going to get through to its intended consumer, and no ifs and buts about it. MQ is going to sit here, so probably a little bit behind MQ in the streaming mode, and therefore even further behind Kafka in the streaming mode. So if you compare MQ's in its core use case and Kafka in its core use case, you are going to see a difference in volume and scale. But that's because you're comparing now two completely different use cases. If I take Kafka and try and use Kafka in that communication model, and I try and tune Kafka, I try and write an application that is using Kafka in a model which is a much more natural communication style, much more natural sort of asynchronous messaging style, it's going to sit here on the scale. It's just not designed for it. Your applications are not designed for it, and therefore you're going to suffer from a scalability and a performance point of view. So now we're in the situation of, actually, what does it mean to be high volume or high scale? You can't just pick one scenario and just say, well, that is what it means to be high volume and scale. Or at least I don't think you can, because if you're going to do that, you might think, well, why are we limiting ourselves to these two technologies? We might as well say, well, let's just program straight to TCP/IP. Or, well, hell, why do we need TCP/IP? Why do we need that reliability? Why don't we just go straight to UDP? We can drop a few packets, we can repeat that stuff. Therefore, if I want real performance, then I'm not even talking about the two best technologies, surely. But there's a reason why we're talking about Kafka and MQ. It's because they do what they do very well, and they provide a lot of value to you from an application point of view. So really, you need to map these against the sort of the feasibility and reliability that your applications are expecting, and what the applications are willing to take on themselves versus what the infrastructure provides them. And if you map these against those, you start to see things move around a lot. TCP/IP, UDP drop off completely. And then within use cases, say in the streaming model, not only does Kafka outperform MQ in many scenarios, but for streaming, but it'll also be more reliable, more feasible. It's designed for it. The APIs are designed for it. The mechanisms, the data storage is designed for it. But similarly, if I look at the communication model, then MQ again not only outperforms Kafka and outscales it, but it will also be a more feasible, more reliable solution because it's providing you a designed for solution in that space. So again, back to the myth, for high volume or scale, it must be Kafka. I don't think you can really make that statement unless you are putting it in the context of what you're trying to achieve. And once you do there, then you get a very different answer. Right. Last myth that I'm going to tackle here and now. You want real time, you need Kafka. Now this is one which is a sort of, maybe it's just me, I don't know. But quite often you'll see a description of Kafka when it's talking about a comparison to Kafka and say message brokers is to say, oh, it's for real-time data processing, real time. And people narrow in on the real-time part, and they start to talk about real-time as if Kafka is there for real-time. And for a long time, it's been like, well, hang on a minute, that's not a unique capability to Kafka. Obviously, other messaging solutions, not just MQ, are providing you real-time solutions in that definition. We're not talking true real-time, but we're talking sort of close to real-time. Then I saw this picture, and I think this made it very clear, or at least this picture helps make it clear as to why people talk about Kafka and real-time data processing. So this is from someone at Forrester. It's called Perishable Insights. And he's basically saying, look, if you're going to get insight from your data, and remember, that's the Kafka use case we were talking about, that data, if I look at it hours, days, or even months after I've collected it, then I'm going to get quite stale insight. Okay, I might get some value from it, but I'm not going to get the most value from it. Whereas if I can look at it, within seconds or minutes of it being generated, then I can start to respond to it. I can action it, I can react to it. In some extreme cases, I can even be preventative. I can see some things happen and try and head them off before they fully form. So real time is about looking towards the left-hand side of this. And what this is a comparison, this isn't a comparison between Kafka and traditional message brokers. This is a comparison between Kafka and batch data processing, which we tend to forget here, because actually, within this space of data, of insights, gaining insights, if we think traditionally what we're doing, we're building up that data and then we're processing it in batch. Whereas Kafka has come along and Kafka has opened up those opportunities for you to be able to do things in real time or within, seconds of it actually occurring. And at that point, we start to be able to get more insight, more valuable insight to that same data. So real time makes a lot of sense where you're comparing between Kafka and batch processing. But if you can compare between Kafka and say MQ, then MQ sits over here too. MQ is over on the left-hand side because messages come into the system and messages go straight out of the system, just like they do in Kafka. If things slow down, if the application slows down, that's why you're asynchronous. The same across both technologies. And if I'm going to be really pedantic, then actually MQ probably nudges it slightly further to the left because of the latencies, because of the fact that Kafka is expecting a continual sequence of data, and to optimize that, it will tend to wait to fill buffers to be able to push things across in a more optimal way. Whereas MQ, if you give us the tiniest of messages and say, right, this message needs to get through now, put that on a queue and make it available to a consuming application, it will be there. So really, if you're going to split hairs, then MQ nudges it slightly further to the left. But the key thing here is real-time is a good way of talking about it, but it's in the context of Kafka providing you real-time insight versus batch processing insight. So we had this as a layout, or my layout of how you see the differences in the two technologies, what they focus on, and this was very much driven by the different use cases. But if you look at those myths, and those myths are repeated time and time again when you look at different articles and the internet's focus, if you go and Google it, you'll find out what that means. As in, you'll find out that Google will tell you the same things when it analyzes what's out there. It tends to be the things laid out on this chart: the persistence, resilience, security, real-time, metrics, scaling, those sorts of things tend to be the things that people single out. And, in my view, those things are pretty comparable. We've already talked, for example, scale. Yes, there are differences. There are definitely going to be differences depending on what you're going to be doing. But within your use case, you're going to find two very scalable, very capable solutions. And the same for all the other dimensions as well. So rather than focusing on that right-hand side way of thinking of it, focus on the left-hand side. So the use case focus. So that then takes me to, okay, then how do I work through that? How do I choose it? Because, I realize I'm talking to a lot of people out there. A lot of you are going to be very experienced in this. You're going to know this sort of stuff. And I'm not trying to sort of convert you. I'm not trying to teach you things that you don't already know. But sometimes these things come up in conversation, and the conversations that I've come into, it's just looking at ways to try and articulate it, start to help to be able to get the understanding across. So one way is to think about, okay, then how do we choose, going through it from an application point of view, and really sort of the sort of coarse grain, rather than sort of fundamental things from an application. Think of it just the patterns. What are the application patterns? You know, we've talked through these already. You know, we start in a decision point. The decision point is, do I do batch processing, or am I real time? Am I trying to sort of interact with things as and when it happens, or am I building up data and then I'm coming back and processing it later on? Now, obviously, we're focusing on the real-time side. So, you know, this isn't to scale. This is just so that we don't keep slicing smaller and smaller slices off of this. So if we look at real time, then the next point of decision is to go, okay, then am I going to be synchronous or am I going to be asynchronous? Now, I said we live in an asynchronous world, but synchronicity also helps. You know, there are certain times when things just have to be done synchronously. And if they've got to be done synchronously, then I get great benefit because it's very simple. You know, REST APIs are nice and simple, but I've got to live with the implication. The downsides of it are I'm tightly coupled. The other end has to be there, it has to be available to me, and I have to worry about that, and I have to maniacally focus on making sure that those systems are there at all times, and also how I manage and maintain them and how I scale them and all those different things come in. So synchronous is great, but it becomes tightly coupled. Therefore, that's why we see normally a combination of two. Some things are synchronous and a lot of things are asynchronous, because asynchronous brings in that loose coupling, that ability to be able to sort of separate out the different stages of your application, of your solution, and bring in much greater and greater systems, you know, that all knit together across the globe. So we focus in on asynchronous. Now we're trying to get to the point where we can start to say, okay, then of these two technologies, where does each sort of play? Where does each focus? First, we have to split it in half. Now, I've called it events and messaging. Now, those names have different connotations to different people. Really, what I'm trying to talk about here is, say, if we look on the right-hand side with messaging, and I've called that loose coupling. Messaging is really about when asynchronously, I want to put a message in and I really, really want that to be processed. I will be really disappointed if it's not going to be processed, because it means sort of, you know, I was expecting something to happen and it didn't happen. Therefore, I'm only loosely coupled. I can't be fully decoupled at this point because I've got a dependency. You know, I'm effectively expecting something to happen. Therefore, I would say I've got loose coupling. I'm as decoupled as possible, but I've still got some tie to the other end. Events, on the other hand, on the left, is much more thinking about it in a truly decoupled way. And to be truly decoupled, you can't really care what happens. Once you push out an event into the system, you're effectively setting it free. You're saying, okay, then this is an event. It was important for me to publish it, but hopefully you're going to process it. But if you don't process it, I can't really hold you accountable for it. So at that point, you are truly decoupled, you know, no regrets at that point. Often events and messaging get split into things like events are things that happened in the past, messages are actions. I think that's too sort of a stark sort of separation, because things can happen in the past and published as an event, but what I really mean is I want someone to pick that up and do something with it. And if I really want someone to pick it up and do something with it, then really I'm on the loosely coupled side, not on the decoupled side. But anyway, let's divide events even further. Let's divide that into event streaming and event notification. Now, I've already talked about event streaming. That is the model that Kafka, you know, really has sort of underpinned and defined to a certain extent, being able to do that real-time sequence of events happening continually throughout time. You know, no real beginning, no real end, and it's just I iterate through these things. Event notification, on the other hand, is still events, and publishing an event, you might be interested in it or not, but it's actually a very different pattern. These events are independent events. You know, it might be events telling me I've got an email or something like that on my phone. That's an event. It's not a stream of events. I don't want to see it in sequence. I don't really care about that. That's not a big impact. And therefore, event notifications have different requirements. They have different axes of sort of scale. You know, am I talking about lots of consumers for a small set of events, or a lot of events on, you know, one or two different topics, or am I talking about thousands of different topics with just a few events on? So I've got a similar volume, but I've got a very different dimension to the scale. These are all justified and equally valid event notification patterns, but they are quite different in actually what you're trying to achieve. So now, based on that, we introduce the two technologies. you can probably guess where they're going to sit. So MQ, for example, MQ sits here. Messaging, definitely. MQ really has underpinned that whole messaging space, that enterprise messaging space now for a long, long time, and very few people would question that. Event notification is very good at too. Event notification is something that MQ has been able to support, and many of you have solutions, very, very capable solutions that sit on top of MQ's publish subscribe, its topic model. If we look at Kafka, then Kafka sits across the event space. Event streaming, definitely, because event streaming, like I said, that's exactly what it's designed for. Very, very tailored for that model, right down to its data model. Event notification, equally, it does event notification very well. But this is where in the cases where MQ excels in certain dimensions of scale, number of topics, then Kafka doesn't do so well. And equally vice versa, where Kafka scales like the number of subscribers to a single topic, MQ again wouldn't excel in that way. So you get almost a nice trade-off between the two. So you're going to make a distinction between the two, but I've simply said there's an overlap here, because there's always going to be some level of overlap. And in fact, there's overlap at all levels. I mean, we're using these technologies for their core use cases. I said right at the start, it's about a technology using it for its, expecting the best and using the best of breed. But quite often we'll use a technology because it's more convenient in a certain use case or in a certain implementation. And we see that, both within the messaging, the async space, but also out into synchronous and into batch world. So generally, these are, there's not a hard rule, but it's about trying to, use the right technology for where it really, really excels. And there's no real other contender in that space. But are things changing? Yes, they are. Things evolve. Things continually evolve. MQ evolves. Apache Kafka evolves. Also, the use cases evolve and how people are using them. So, for example, the first thing to mention here is if we look at, say, between event streaming and batch, remember that was when I was talking about real time. It was very much about, okay, then what we're seeing is a move from traditional batch workloads, building that work up and then processing at the end of the day, to actually, maybe I could do that in real time. Maybe I could do that with a Kafka-based solution. Maybe I could have Apache Flink processing that in the background. And at that point, I start to see a growth in event streaming use cases. So that's one change. But we also see changes from a technology point of view. And at that point, I'm talking here, at IBM TechCon. So, and I've just explained to you why we see great value in having both of these technologies, because they really are designed for the different use cases. And the use cases, there's a little bit of overlap, but actually there's a lot of difference in what you expect from your technologies, depending on what you're trying to achieve. And I can do that because we have both of these technologies. We have IBM MQ, and we also have Apache Kafka in our event automation portfolio. But if, say, I was just trying to push one technology, then maybe I'd think a little bit differently. Maybe I would think, actually, how do I try and convince you that this technology can be used for a space maybe it's not particularly designed for, or at least initially wasn't trying to go after, but now maybe it's starting to realize that not everything can be rewritten into a particular pattern, and one pattern can rule them all. So that leads me into this space. So from the Kafka world, there's definitely that feeling, there's that vibe, there's that thinking that, okay, maybe this messaging thing, this asynchronous communication is an important thing, which some of you may have come across, a new capability. A new capability is not quite there yet, it's still in early access, but queues for Kafka. So some of you may be nodding at this point. I know when I've spoken about this publicly just a couple of weeks ago, I had a few nods from the audience, because a lot of talk is happening about this, because, well, this is an interesting idea, isn't it? If I introduce a queue concept on top of Kafka, maybe I get the best of both worlds. So I'm just going to spend a few minutes just unpicking this just a little bit, okay? So queues for Kafka. It's a new feature. It's going to go into Apache Kafka, so it's going to go into open source. It's in early access. Kafka version 4 came out relatively recently. So that will evolve into a a productized capability at some point. So this is queues for Kafka. That's what it's called. That's the title of the feature. That's the capability. So what is a queue? Now I have to hold my hand up and say I'm a little bit embarrassed to say, it's like CTO for IBM MQ, and I struggled to write down a definition of a queue. I started going down different avenues of, well, this is a queue, but that's underplaying the value of a queue, so let's go this way and that way. And then I started looking around for, okay, maybe I've missed it. Maybe there is a standard definition of a queue. And that's sort of easier said than actually found when you go out and look for these things. But I did come across this, and I'll explain where I got it from in a minute. And this lays out 4 key characteristics of a queue: asynchronous communication, first in, first out, FIFO, durability, and message deletion. So I'll just go through the description of these because I think they fit pretty well. Asynchronous communication, this is a sort of given. Message queues allow producers to send messages via the queue without needing the consumers to be ready at the same time. Ignore the barista coffee shop, barista coffee shop analogy there. But basically, things can come into the system, they don't have to be processed there, and then they're decoupled, they're loosely coupled. So yeah, we understand that. First in, first out. Now this one's an interesting one because it's actually saying FIFO is important, but it's not everything. Message queues typically follow a FIFO pattern. They're shared queues where the ordering is not guaranteed. So the characteristic of a queue here is saying, generally you want to process stuff in the order that it came in, but there might be reasons why actually the ordering is not the most important thing. Sometimes ordering can get in the way, ordering can cause problems, and we'll see why in a minute. Then durability. The key thing here is the messages will wait patiently in the queue until they can be processed. So basically this comes back to that trust thing. I can put a message in, I know it's in the system, I know until it's consumed, it's going to be there, it's going to be available to you. And then message deletion. Again, when we talked about the queue concept, the asynchronous communication model of how you want things to go into a queue and then come out of a queue. So each message is typically consumed by one consumer instance, ensuring exclusive delivery. You don't want things to happen more than once. Messages are deleted after being consumed or acknowledged by a consumer. This ensures that no duplicate processing occurs and the queue is cleaned up over time. So these are the 4 characteristics that were chosen for a queue. And when I read that, I thought, that's a pretty good definition of a queue. That helps. That helps define, particularly if you're not familiar with what a queue is, that helps define really some of those core characteristics. Now, interesting, just to show that, I'm not trying to lead the witness here. This was written by Confluent. This was written by a guy at Confluent. If you're not familiar with Confluent are sort of the spiritual home of Kafka. There are a lot of the originators of Kafka there. And it's actually in describing the queues for Kafka feature. So, okay, then this is defining what a queue is. And I think if you were to look at MQ, I don't think anyone really would disagree that MQ ticks all of those 4 boxes. If it didn't, I don't think it really would justify its use as a message queuing solution. So that's what a queue is. So now let's look at what queues for Kafka is. And to do that, first thing is we have to understand that it's not introducing a queue mechanism. It's not introducing the abstraction layer called a queue. Instead, what it's doing is adding a new consumer capability. And to understand why, let's look at the existing consumer capability. So if we look at Kafka and consumer groups, I can't really go into great detail about this. I'm sure many of you, if not all of you, understand this. But the key thing with Kafka is I publish to a topic, I partition my topic up into separate, like sort of mini queues. Let's call it a queue for now. And then the messages get distributed across them. So the analogy here that I've made up is I'm standing in line with my groceries. Basically, there's 3 tills, and I pick a queue at the start, and I carry on through that. And then what's happening is at the front of the queue, then each person with their trolley is getting processed. They're going through, they're paying for it, and they're moving out the other side. And then the next one, and the next one, and the next one. So that's sort of the way that consumer groups work in Kafka. That's great because it gives me some horizontal scale. So that distributed nature. It also gives me ordering. It means that once the ordering is defined on the way in, that ordering will stay within that lane in the order that it came in, so when it's processed. Across the different lanes, then there's no ordering guarantees, but at least I get it within each lane. So now for the tricky bits, now for the bits where we're thinking, okay, then maybe things could be better, or maybe other solutions are a little bit easier here. So for example, say things get really busy and those queues get very, very long. I can't bring in a 4th cashier. I can't bring in someone to say, okay, then start processing from those 3 queues. I needed a 4th queue, a 4th partition to be there for me to be able to consume from it. So at that point, I can't really dynamically scale. What you tend to do in reverse is you tend to over partition and then have fewer sort of caches processing them. Some caches will have 1 or 2 or 3 or 4 of those all in parallel. And that's okay, but it's a little bit inefficient, or it is inefficient, if that's all you can do to then scale up to the maximum number of partitions that you originally set. So you've also set an upper bound. So dynamic scaling is not a good feature here. There's also another problem, which is because you're going through this in order, you can't skip over. You can't, I mean, if you do, you're just losing that message. But the key thing is that if you say I can't process, or you fail to process that, you'll come back in and you're processing the same message. You keep going back over and over and over again. You have to proactively go and sort of effectively try and push past it. So everyone behind is obviously building up and having a problem. So that's a traditional Kafka consumer group. Queues for Kafka introduces a Kafka consumer share group. And the share group works like this. And the analogy that I came up with, which may or may not work for you, is if you're going through passport control. Particularly I find in the US and many other countries, you tend to have a long snaking line with those little barricades. And then you get to the front and then someone is saying, okay, then you and you go to number 4, you and you go to number 8, and you go to number 17, and then you go to the officer and then you hand your passport in. So you sort of, rather than having those individual queues defined up front, those partitions, these things sort of get compressed into one thing. And then at the very end, you get little mini sort of batches of broken up and shipped out to whoever happens to be available at the time, whoever is in that consumer group. So that gives me good benefits, because it gives me a benefit now that if the queue is getting longer and longer, I can bring in a 5th officer, and that officer can now, the next time Kafka dispatches the next batch of messages from the front of that one snaking queue, some of them can go to that new officer. So I've dynamically scaled. So that's a good positive here, because I haven't had the problem that I've got on the left-hand side, which is I can't scale past my number of partitions. So that's a good plus for this. It also introduces the fact that if I've got a problem message, rather than blocking and just reprocessing that message, I can basically sort of say I've had a problem with this, and other messages get processed around it. And I can do that for a certain number of times. Then after a certain amount of time, then it says, actually, I'm never going to be able to process this message. Now, at that point, it does just skip over the message. So it's not ideal there, because it doesn't like move it off to a dead letter queue or something, which is what you'd expect, say, with MQ, but it at least allows you to move forward. So the benefits here, I've got dynamic scaling, and I've got the ability for messages to move around other problem messages. Now, obviously, the downside of that is I've lost ordering. I don't get ordering at this point. I get general ordering up until the front, and then at front it's, everyone goes for it as quickly as they can, which that's not knocking it. That's exactly what you get with MQ if you've got multiple consumers against a single queue. You get that, but you get that on individual messages. So you can sort of see why you've got this. You've got share group. You could bring in the benefits. You sacrifice your ordering, but you get that dynamic scale, and that's something that more and more people are finding as limitations around Kafka. So if we now look at the key characteristics of a queue from that article and now apply what we now understand about queues for Kafka, what does it do? Well, asynchronous communication, traditional Kafka, that's a green tick. That was already a green tick. That's basically saying, okay, I put stuff in, I can process it later. No one's disputing that you can do that with Kafka. The FIFO side, then that's an amber tick for traditional Kafka, because I'm forced into being ordered. I can't really do anything else. And as we've seen, sometimes I really need ordering. For event sequencing, I need ordering. But if I'm doing work that's a work queue or something, then maybe that last bit of ordering, the downsides of that, keeping that ordering, they're not worth it. And therefore, I want to sacrifice ordering and have something else. Whereas I don't have that with traditional Kafka. Durability. The message will wait patiently in the queue until they can be processed. This is an amber tick as well, because messages will stay in Kafka and they'll be durable and very resilient if I'm doing replication and everything. But as we said earlier, they will stay there until you've configured your topic to say remove those messages. It's nothing to do with whether they've been consumed or processed. It's really purely dependent on how you've configured your system. So if you've got a big build-up and those messages are going later and later and later and later, they might time out before they get processed. and therefore that's why you get an amber tick. It's not bad, but it's not perfect. And message deletion, the ability to say exclusive consume, no one else can do it, and once you're done, it then gets removed from the system. That's not the Kafka model. Remember, the core Kafka model is built around it's an immutable log, and we don't change this. That's what Kafka exposes to you. Now, my consumer groups, I can have offsets and things that say, okay, then I'm going to move forward. So technically, I might not see that message again. But if I restart, if I have a different consumer group, different consumers can see it, or if I have to reset that consumer group for whatever reason, I'm going to start to see those messages again. So, you don't get everything, that you want. So you get a red cross there. Now, if we look at queues for Kafka, same green tick for asynchronous. FIFO, we now get a green tick because we've got you two options. You can stick in order, or with queues for Kafka, you can give up on ordering, but you get the more dynamic capability. So I get a green tick there. Durability, that doesn't change. We haven't changed the way that we store messages in Kafka. We haven't changed the way that messages time out in Kafka independent of the application, whether they've been processed or not. So it's still an amber tick. And exactly the same for message deletion. Even though we've now got capabilities that say, okay, then this message is now being seen by this consumer group, and therefore, until I reset the consumer group, like my offset, I'm not going to see it again. It's not deleting it. It's still there in the log. It's still visible. Remember, we talked right at the start, MQ has the same log behind it, but it abstracts it away in the form of a queue, and therefore the queue does not let you see these things again. Whereas by exposing you the log in Kafka, both for traditional consumer groups and for share groups, you are able to see those messages and other consumers can see that message. So we've really changed the FIFO behavior. So that's a good thing. Queues for Kafka is a good thing. It's helped with that static scaling problem, which has been there from the start with Kafka, but I compromised the ordering. It helps with the head of line blocking, the ability to move around a message, but again, it compromises with ordering, and it introduces that possibility that messages just basically evaporate. You just move past them and nothing really happens to those messages. So benefits, but obviously downsides. Also, and this was just me listing a few things when I started trying to define what a queue is, these are all different things that you could equally say this is what a queue is. It gives me end-to-end back pressure, selected message retrieval, exactly once delivery, transactional processing. There's lots and lots of things, and it carries on going. So even within the definition on the screen, queues for Kafka isn't really giving you a queue abstraction. And as I explained right at the start, the queue abstraction is what really suits that asynchronous messaging model. The log and the event stream, which Kafka exposes, fits the event stream processing model. So even this, I don't think really moves the needle much into that asynchronous messaging space. It more solves some of the limitations that I have around some of the ways that Kafka forces you down one particular route. Right, so what does IBM bring? We've been talking about decoupling interactions, we've been talking about gaining insights. Now, obviously, on the left-hand side, we've got IBM MQ. Many of you will be familiar with it. Throughout this week, you're going to hear about all the great things we've done in that space most recently and how you can really, really benefit from that. On the gaining insights side, that's where Kafka sits. And for that, obviously, Apache Kafka, it's open source. You can take that, you can use it, you can benefit from it. IBM offers that in IBM Event Streams. IBM Event Streams takes Apache Kafka. It combines that with other open source technology. It brings in our own support, our own capabilities, and packages that up as a very enterprise ready and enterprise grade Apache Kafka for you. But we haven't stopped there. We've looked at this gaining insight space, this event streaming space, and gone, well, okay, then Kafka is an engine. A Kafka is the broker that is where you put the data, but it doesn't stop there. For a start, if I really want to benefit from having these event streams, these sequences going on and all these topics generating this data, and I really want to sort of get that data democratized so that other applications can consume it and gain insights from it, then I need to be able to manage it. So that introduces IBM Event Endpoint Management, where I can actually see, I can describe my different topics and I can explain what they are. I can define how you interact with it, and through our event endpoint, our event gateway, we can actually police who can access them. That brings sort of control to that space of just randomly publishing to random topics in the hope that someone is going to get some value from it. And then we've actually got the task of how do I actually then get the value out of that data? How do I process that data in a way that I really can gain the insights? Remember, this is what it's all about. It's about gaining insights. And that's where IBM Event Processing comes in. So IBM Event Processing is under the covers, that's Apache Flink. And you may have heard of Apache Flink. It's sort of the leading event stream processing technology out there. And that event stream processing technology is great. It's very powerful. It allows you to create some great event flows to sort of really understand what's going on and combine different flows and work out what the, what the impact of these are. But it's also quite a complicated beast. It's particularly complicated to write those applications or those flows to actually interact in the Flink model. So what IBM Event Processing brings to that on top is a low code, no code canvas. So at that point, it starts to make it much simpler for you to get value out of those event streams. Now, all of those fit together in IBM Event Automation. So at that point, you might be thinking, okay, then I need those three technologies. I need to be sat on top of IBM Event Streams with Kafka within it before I get to event endpoint management or event processing. But it's not actually the case. We're trying to be as open environment as possible. And therefore, these are composable capabilities. You can take any of these capabilities and work with other capabilities. So for example, I could take event processing and run that against Apache Kafka that you've sourced yourselves, or you take from a third party. The same for event endpoint management, whether that's a cloud provider or a vendor that is providing you your Kafka system. So you don't have to have a top to bottom stack implementing, sort of taking the whole IBM path to get real benefit from what we've put into that event automation space. And you're going to hear more and more about that throughout this week if you stick in this track, which I hope you all do. So what have we learned? We've learned that it's all about the use case. It's not about the scale, it's not about the age, it's not about those sorts of things, it's about the use case. Pick the use case, understand what you're trying to achieve, and then at that point, that's when you need to pick the right abstraction level. Is it a queue? Is it an event stream? What makes sense from an application? What's going to be make sure that the application works the best, the technology fits it the best, and leaves as little room for sort of problems in the future as possible. And then finally, if you want the best, you're going to probably need MQ and you're going to need Kafka, because as the space is evolving, particularly as batch is moving more real time, then you're going to need that event sequencing, that event streaming capability, and that brings in Kafka. And you're obviously going to need that asynchronous communication, because that's what makes the world systems run. So on that, I will stop. I'll hand back to you, Ray.
Perfect. Thanks, David. Great session. Thanks, everybody. You'll see a survey pop up here in just a minute. If you could fill that out for us, we would appreciate it. And just to remind that at the end of the day, we're going to have office hours where all of our speakers through the day will be on alongside me, and it'll be kind of an open question and answer session. So keep that in mind. And our next session that we're going to jump over to is with Kim Clark and Martin Evans on more than queues and topics. All right. So thanks for joining. We'll see you on the next channel.